integral of u to the 1/2 du. So taking the antiderivative of this, we raise the power 1 and we get u to the 3/2 times 2/3 plus c. But u is tan x, so this is 2 tan x to the 3/2 over 3 plus c. Alright. Now I'm going to go a little bit quickly here because of time. Tangent. The way we integrate tangent is that we change it into its sine and cosine component parts. So this is going to be the integral of sine of 4x plus 2 over the cosine of 4x plus 2 dx, and then we let u equal the denominator. Well, what is the denominator? It's cosine of 4x plus 2. And then we take the derivative of both sides and we get negative. What's the derivative of the inside here? 4. So that's 4 sine of 4x plus 2 dx. Now what do we have in the integrand? Sine 4x plus 2. So we're going to solve for this by dividing by negative 4. So this is du over negative 4 equals sine of 4x plus 2 dx. So on the outside of the integral, we get negative 1/4 times the integral of 1 over u du. But what is the antiderivative of 1 over u?
ln of absolute value.
That's right. Negative 1/4 the natural log of the absolute value of u plus c. And we know that u is cosine 4x plus 2. So this equals negative 1/4 the natural log of the absolute value of cosine of 4x plus 2 plus c. Moving right along. Secant x. This is one I actually did for you in the notes. This is the seemingly bizarre factor of 1. So this is secant x times dx, times secant x plus tan x over secant x plus tan x plus c. So when we do that, we create a du in the numerator by getting secant squared x plus secant x tan x, because both of these are somebody's derivative. And whose derivative are they? The functions in the denominator. So this is secant x plus tan x dx, and in this case we're going to let u equal the denominator. So this is secant x plus tan x du equals secant x tan x, because the derivative of secant is sectan, plus secant squared x times dx. And thankfully we have that in the numerator. This becomes our what here? Du, and then this is our u down here. So then we have the integral of 1 over u du, which is just natural log of the absolute value of u plus c. So then we replace our u and we get the natural log of the absolute value of secant x plus tan x plus c. Next one, 55. This is a definite integral because we've got the integral from negative pi over 4 to 0, which means we're going to use the fundamental theorem of calculus part 2. In order to use the fundamental theorem of calculus part 2, we have to find the antiderivative of this. You see a function and its derivative anywhere?
Well, secant squared x is it?
Secant squared x is the derivative of, so what's your u? Tan x. No, right? Because we need a du that goes along with u. So u is tan x. Du is secant squared x dx. integral. Now, when I change my variables into u's, these no longer apply because these are in terms of x. Okay? So when you change it to u, you just leave the limits of integration off until you go back to x. Alright? Because it's not equivalent. You're just using u to help you find the antiderivative. Okay? So let's do that. We get then u du, whose antiderivative is u squared over 2 plus c, but when we're doing a definite integral, do we need the c?
No.
Nope, so now we're going to change this back to x. So this is going to equal then, what is u? Tan squared x over 2 evaluated between, good, negative pi over 4 and 0. Alright, well, so let's plug in 0. We get the tangent of 0 quantity squared over 2 minus the tangent of negative pi over 4 over 2, and the tangent again is squared. So the tangent of 0 is 0. So this is 0 minus tangent of negative pi over 4. So that's, this is down here, right? Negative pi over 4? Negative 1. Right?
Right.
Negative 1 squared
1.
over 2. So this is negative 1/2. Alright. 57. What are we going to let u be here? What's being raised to a bigger power? Well,
No, the 3 over 2.
well, okay, so I would let u here be 1 plus theta to the 3 halves. Why? What's the derivative of that?
It's
3 halves, theta to the,
1/2.
do we have a theta to the 1/2 in our?
We do.
We do. So this is d theta. But we don't have a 3 halves. So we have to multiply by 2/3 equals theta to the 1/2 d theta. So I'm going to pull the 10 out as well. So that's going to be 20 over 3. If you're following that?
Yeah.
Times the integral. Now I'm in terms of u now, so I'm going to leave the integrand limits of integration off. So then we're going to get 1 over u squared, which is u to the minus 2. Can you make that leap with me? I'll do it in 2 steps. The way Robert's fate was crunched up, it was probably best to do it this way.
It always is, don't worry.
Okay? Do you see? That's because the integrand I said was u is in the bottom, right? So it's 1 over u squared.
Yeah.
But that's u to the
2.
negative 2.
Negative 2.
So this is 20 over 3, integral of u to the minus 2 du. Antiderivative of that is? Good. Negative u to the negative 1. And I'm going to leave the plus c off because we're not going to use it. So this is going to be, if I rewrote it, negative 20/3 over u. Right? Or negative 20 over 3u. But what is u?
Wait, how'd you get?
You raise the power 1 to the negative 1, then the divide by negative 1, right? So this will be negative 20 over 3 times u, which was 1 plus theta to the 3 halves, evaluated between 0 and 1. So let's plug the 1 in and we get negative 20 over 6. 6?
Yes.
made that division bar very large for 6. I'm being too picky. Alright, now what happens when we plug in 0? We get minus.
Negative 20 over 3.
So if I find a common denominator, which would be 6, this will be negative 20 over 6 plus 40 over 6, which is
20 over 6.
20 over 6, which reduces to 10 over 3.
Yep.
There we go.
Please pull up. Thank you.
What will we let you be here?
These 1t to the 5th plus 2t.
Yes, it's going to be t to the 5th plus 2t. Why? What do you see in the integram?
It's derivative.
Its derivative. So you see a function and its derivative. So you're going to let the function be u, which is t to the 5th plus 2t. And then du will be 5t to the 4th plus 2 dt, which happens to be in the integrand with it. So then this turns out to be the integral of u to the 1/2, good, du. If you take the antiderivative of that, you get u to the 3/2 times 2/3. And then we're going to plug in u, and we know that that's going to be 2 times t to the 5th plus 2t to the 3/2 evaluated by, or divided by 3, evaluated between, is it 0 and 1? 0 and 1. Let's plug in 1. Well, that's 1 plus, God bless you.
Thank you.
1 plus 2 is 3, so that's 2 times the 3 to the 3/2.
Square root of 2.
Square root of 27, right? If I cube the 3, I get 27. So that's going to be 3 root 3?
Yeah.
Oh, goodness. Over 3 minus what happens when I plug 0 in? Hallelujah.
0.
We get 0. And so then these 3's cancel and we're left with 2 root 3 as our answer. I cannot stress enough how important 7-2 homework is
Very good.
to your livelihood the rest of the semester.
To our livelihood?
Okay? So